Hello, come on in, take a seat. We got tons of room up here on the left. Welcome. My name is Ryan Jarvinen. This is our new Red Hat logo that we just unveiled today. Did anyone notice the change? We've had a couple t-shirts with a new logo we've been handing out in the marketplace downstairs, and some cookies as well. So I'm here today to talk about extending Kubernetes with the operator pattern. Or the operator framework specifically. How many folks in this room are already using Kubernetes in some capacity? That looks like probably 2/3, 3/4 of the room or more, and then maybe some people who didn't feel like raising their arm. I'm expecting probably a good amount of interaction with folks from this audience. We did one of my coworkers, Josh Wood, had a very similar talk last year on the schedule. He actually had a 5-minute keynote that was real focused on this topic. So we've been kind of speaking to this audience on this topic for a little while now at previous OpenStack events, and hopefully this is still appropriate with the expanded focus on open infrastructure and anyway, I really like what Kubernetes brings to the table, so we'll dive into that a little bit through the course of this presentation. So I introduced myself a little bit. I'm Ryan Jarvinen. I'm a developer advocate at Red Hat, and there's supposed to be another graphic on this slide. I'm a little nervous because there's missing images right here, and I'm hoping that the rest of my slides don't have missing images. Let me double check. I made a bit.ly URL called bit.ly extended infra. So I'm going to reload that and cross my fingers and hope I get all of my graphics to show up appropriately. Okay. No, thank you. All right. Oh, there we go. It's this transition. It was hiding. So yeah, I'm part of the Red Hat's OpenShift team. We have OpenShift is kind of Red Hat's distribution style approach. We've chosen to solve things like we always do, which is solve it with a distribution. Red Hat has CoreOS and CentOS and Fedora and of course Red Hat Enterprise Linux that are all Linux distributions that are geared towards making you successful with the Linux kernel and a related collection of tools that go along with helping you be successful and productive with the Linux kernel. So we take a similar approach with Kubernetes and OpenShift. We kind of see Kubernetes as the core scheduler of this cluster scale operating system, and OpenShift helps provide all the collection of tooling that you would need in order to run Kubernetes equally well on any cloud and any infrastructure. That means anytime there's specialized functionality, we try to give you a software implemented, soft infrastructure, fully open source solution that's part of an open source distribution around Kubernetes that gives you the assurance that when you go to deploy that Kubernetes solution, it will work equally well on any cloud, because when it comes to logging aggregation, you're not pinned into just Google's log aggregation or Amazon's log aggregation or any other kind of soft infrastructure type feature. You can have that all implemented in software, and then if you have custom hardware that you want to bring in, you can always bring in that higher performance specialty hardware, load balancers, storage arrays, and other things, of course. So we don't try to give you a super opinionated version of Kubernetes, but it does have quite a lot to it that goes into helping you be successful. So why should you care about operators specifically? Operators are kind of part of the state of the art that we have arrived at after working at expanding Kubernetes and getting it to work really well with this added collection of features, right? So operators are kind of a design pattern that we've stumbled on throughout the course of expanding the Kubernetes platform and adding custom functionality to the cluster. So if you're doing basic work with Kubernetes, your most common workloads are going to be stateless apps. Of course, that's covered really well with Kubernetes, but that's not necessarily the majority of the workloads that you're running. When it comes to stateless apps, you can run a command like this, kubectl scale. This particular command is targeting the API and impacting a deployment resource that has a deployment ID of static web, and then we're setting a particular attribute within that resource on the API. We're gonna set the replica value to 3. And so that ends up updating some YAML or some JSON somewhere in our etcd database behind the scenes. But from the user experience, they just state, here's what I need, and Kubernetes goes to work documenting their request and then trying its best to fulfill that request. So here's an example from the command line. Someone might run this kubectl command from their laptop. That would send that scale up request across the network into Kubernetes. Kubernetes has a resource or a controller, I should say, and an API object that covers this replica set object, and it's going to record your desired replication count of 3. It's going to look at maybe what the current state of the platform is, and if the current state or your previous state was a replication level of 1, it's going to then take note and say, well, our spec request is 3, the actual status of the data is 1. I'm gonna compare these two, and I'm gonna proactively go and make some changes. I'm gonna spin up 2 new pods, and it'll go talk to the Kubernetes API and say, Kubernetes API, I need a new pod. Pod is their terminology for a group of containers that needs to be provisioned. So this would be kind of the interaction of how you would tell a higher order resource, like a replica set, what you need, and then this higher order resource goes and takes actions on your behalf and goes and fulfills the request, scaling you from 1 to 3 of this collection of containers. Once the spec and status are back in alignment, this replica set controller is still going to watch and observe. It's going to check on an interval, and anytime these two fall out of alignment, it's going to do work to either add more containers or remove containers as needed in order to make sure that these are always at a nice balancing point. So that's pretty easy. It's nice that Kubernetes can automatically readjust if one of those 3 in the collection suddenly goes missing or gets deleted or crashes or anything happens to it at all. Especially since it's stateless, we don't really have to worry about the loss of state in those cases, right? So we can quickly replace those things at a rapid interval and not have to worry about what happened to the missing data, because we didn't account for any in that model. So what about apps that store data? What do we do in those solutions on Kubernetes? Well, the initial solution is you'd take the same type of command, kubectl run. You'd name your image, you'd name your deployment. This deployment is named DB. We'd reference which image we would like to deploy. That could be any registry that's referenceable from the Kubernetes cluster. Pretty simple stuff. This allows us to provision the image. It gets us some amount of assurance that we're always getting the same image checksum and some reliability. But just starting the image, that's really, not very impressive for, let's see if this adapter will cooperate. Yeah, the screen down here is totally solid, so I don't think it's this adapter, but hang tight and I'll walk us through this. So running a database over time gets to be a lot more challenging because it's not just the initial startup that you're concerned with. You have a user population that you have to interact with, and some folks are going to expect that over time this database may need to be resized, may need to be upgraded, may need to be reconfigured, might need backups, might need auto healing. There's a whole collection of site reliability engineering tasks, database management tasks, a whole lot of specialty knowledge that you and your team members probably have spent a lot of time cultivating that goes along the lines of propping the balance back in place. Kubernetes can know the difference between your spec and status, but if your spec and status doesn't reflect the entire story and you're having to manually prop up this thing and manually manage the whole thing, you're not really getting the full benefit out of this fully automated platform. So how do we cover and account for all of these cases? Well, there's two main things that we need to keep in mind. Every application is basically, every workload is in this type of category. Everything needs to be installed, configured, upgraded, and managed over time. And also, at every point along this management timeline, anytime you're doing real production workloads, you're gonna want to keep an eye on security and patching, right? If you're not able to continually apply security patches when you know full well that there's outstanding vulnerabilities, if your workflow is getting in the way of your security posture, then you're headed down a path that's not giving you the right level of productivity. Let me redetect the monitors and see if that gets us back in business. Detect monitors. Keep that.
So this one will go away.
Okay. Oh, that's a whole different presentation. Okay. All right, patching is critical to security. That ought to get us back on path. Anyone want to argue with me on that one? I didn't think so. All right, good. That's a easy win for me, right? Patching's critical to security, and anything not automated is slowing you down for sure. And as soon as you go to adopt these shiny new platforms like Kubernetes, and you see, wow, this is great, spec and status, this automatically balances, and you solve this one, a pretty major case for distributed computing, but then you have so many different edge cases and so much learning to do where you're struggling with the metaphors that are provided by Kubernetes, where they don't quite fit the bill for the custom workloads that you have. That's the parts of Kubernetes that are gonna slow you down. You could get sunk really quickly in terminology and in trying to swap all of these custom pieces where none of them really fit with what you're trying to do. So if only you were able to teach Kubernetes all of your custom skills and distribute it to any cluster of your choosing. Wouldn't that be great? Where if you could actually not just deploy a container image, but deploy custom functionality to extend the platform in new ways, right? So you have this great knowledge in your head. You know what's slowing you down. You know what the work is that's a daily drag, right? If you could package that up, put it inside a box of some sort, and distribute that to any Kubernetes cluster, that's really what operators are here to help provide a solution for. They are really trying to address that issue of automating, being an automated software manager that has full visibility into your workloads and access to the Kubernetes API so it can go and make changes on your behalf and continually rebalance the equation and get you specifically what you asked for in your spec, regardless of the status of what's happening throughout the cluster. So there's two main mechanisms that we use in Kubernetes to achieve this. The first piece is called a custom controller. So you could look up this term within the Kubernetes documentation. Custom controllers allow you to extend the functionality of Kubernetes by basically it has a container with a API key of some sort, and it contacts the Kubernetes API and does a listening API request where it just gets a streaming connection and gets updates on a certain topic. And it could subscribe to a couple topics of updates and then automatically respond. And so it'll look for, has the status and the alignment, status and the spec dropped out of alignment, and do I need to jump in and take action? That's what custom controllers would do. The other major piece that operators provide is something called, they leverage something called custom resource definitions. This allows you to extend the Kubernetes API, and if you're looking for a solution that does something like a deployment, or something like a pod, or something like a replica set, but with slightly different behavior, you could make a higher order abstraction using a custom resource definition, and then teach that higher order abstraction how to use pods, deployments, replica sets, but then watch for whatever the edge case that you need to look for, and then proactively take action and rebalance the cluster using specific algorithms that you've kind of detailed in the custom controller logic. Does that make sense, these two pieces? So these are definitely things that if you want to dig into specifics in the Kubernetes documentation, custom controllers, the custom controller manager, and custom resource definitions. So if this blue outline were a Kubernetes environment with the custom controller manager running, we could then deploy an operator, which is a package that has the, like I said, custom controller. It has a custom resource definition. It can sit within the Kubernetes environment. We can even have a kind of an official resource definition, YAML or JSON. Kubernetes does not care. You can use both interchangeably. So if half of your team is standardized on one thing and the other half doesn't agree, this gives you the chance to make everyone happy and add your own resource types. So this kind production-ready database is something that Kubernetes has no clue about. But you could define, here's what I think what production-ready database means to me, right? You figure it out. You can version this, and then you can actually upgrade this packaged knowledge over time. Because your experience and your special job skills aren't something that you can just codify once, deliver it to Kubernetes and say, and now I can retire, my job is done, right? You have a job that there's problems that change over time, and your best practices for how to solve a particular solution is something that's going to change over time as well. And so we'll get to that a little bit later in a product we have called the Operator Lifecycle Manager. And that allows you to actually upgrade operators and distribute, if you had a new API version for this operator, and you were producing the operators, but I was using them in my cluster and leveraging some open source code that you're producing, I could use the API version and some pinning information in my spec, and I can say, I would like to roll this custom resource, roll it forward to a new release. And hopefully this custom resource is smart enough to achieve zero downtime deployments in production, just like all the fully stateless workloads do in Kubernetes. And if it doesn't, I should be able to go in and teach it how to achieve that by adding more custom controller code. Does that make sense? So in this particular example, I'm setting the spec to a couple attributes here. I have a cluster size of 3 and a read replica value of 2. And And the idea is I can have, this isn't just for me, but this is also for the developers within my workspace. So if you wanted everyone in your engineering team to all standardize on a specific version of Postgres or a specific version of anything, really you can wrap up all of those requirements and give them a clean way of rolling forward and rolling back between one kind of supported release within your org, and they could change that version tag and watch the impact as it applies those changes and rebalances the difference between the spec and the status. So like you could see here, the custom controller code on the left with the letter A in there is taking an action and going and adding our 3 replicas, fulfilling that spec that we asked for. So we can see a live example of this. One example that we demo pretty frequently because we've been working on this one the longest. This one probably has the fullest list of SRE features supported within it. You can do things like, it's a highly available data store, so you can destroy the primary or the master instances, and it will automatically hold a leader election and elect a new leader and reconfigure the cluster so it now has a new leader, and then you can continue the process and destroy primaries or replicas as many times as you want. And it will just keep adding new nodes and reconfiguring the data store dynamically to point to the new nodes. If it even loses more than half the nodes where it's lost the ability to achieve quorum and elect a new leader, then it can basically dump the whole data store and restore the whole thing from the most recent snapshot. So you have a lot of functionality going into keeping this thing up regardless of how major the outage is. Even if the whole thing goes missing, you can build it all over from a recent snapshot. Rolling upgrades, all that type of stuff works really well with this etcd operator. So if you'd like to see one that's very advanced, this is a good example to look to. So here we've got this one pegged to etcd version 3.1.0, and then this example kind of shows how you could go and tell the operator, I'd like to change from 3.0.9 to 3.1.0, and it'll do a rolling upgrade of the cluster without any downtime to the data store. Any questions on how this particular one works? Feel free to try it out. There's a lot of great examples. One site I like going to, we have one called play.etcd.io. Some of this is really kind of showing the functionality of etcd and how etcd can do this auto healing more than what an operator can do. But the whole rolling forward from one release to another and adding new members and having them join the cluster appropriately is all extra work that the control plane needs to be informed and updated so it can reroute the networking in response as these changes happen at the data layer. So we've got a little video I can roll through that demonstrates this etcd operator creating a custom resource definition and adding it to the Kubernetes API. So here we're running kubectl create on a YAML file. That's going to add a new service account so we have the sufficient privileges for managing all these resources. Since we need to talk directly to the API, we need some type of credentials. We're going to create the operator, which is going to add a new API resource and an endpoint that we can interact with. Once we have that operator can monitor the API for custom resources, and that'll be our request where we can specify the spec, and the operator can report back on changes in status. Whatever status we need to look for, the operator and the custom controller logic are going to keep watching and keep reporting back in the status area. So now we'll check to see if the deployment is running. Looks like we've got a deploy that's currently set to a single instance. And we could take a look. Oh, it looks like we're set to 3. Desired count is 1 for the operator itself. Our desired count for the etcd instance is going to be 3. So let's do create on that YAML. Normally, Kubernetes would not know what a etcd cluster is. Now it knows what it is because the operator has extended the Kubernetes API. So here's the cluster going to work, fulfilling our request. We have another command line tool called etcd-ctl. This is similar to kubectl. It's just interacts directly with the etcd API. So this is an example of talking to the database directly. Some of these operators have their own command line tooling as well, but the goal with these is just you ought to be able to use a standard kubectl and manage the YAML or JSON directly. The goal is you shouldn't need any special command line tools generally when interacting using operators and custom resources. So it looks like our cluster is starting up. 11 seconds. We've got here we're scaling up. We've got more pods being created, coming online. Some of these messages are printed multiple times because there's multiple alerts that fire in the Kubernetes API with different messages, and then it's dumbing it down into human speak to something less abstract. That was it. So did that make sense? Did people see how we created some custom YAML that said we want 3 pods? We used kubectl to store that in the Kubernetes API. It was a custom resource object called etcd cluster. So we were able to extend the API with a new resource type. And then we were able to set a spec on that said we need 3 pods. And the custom controller logic took a look, said how many pods do you have now? Currently it's 0. I'll start adding new containers, provisioning new containers until we're up to the requested amount. So that's the mini pre-recorded demo in here. I have more demos I can show as well, depending on how much time folks want to spend on demos or questions. If you would like to try this out hands-on for your own purposes, I would definitely recommend going to, here, I'll leave this up for if anyone wants to take a photo of this URL, learn.openshift.com. This website is available long-term. The nice thing about it is there's no sign-up required. You don't have to enter your email address. You don't get a follow-up phone call. You don't have to enter a credit card or a password or anything. You just get, you connect to this website. We boot up a virtual machine with OpenShift running in the background. And we even set up a little terminal prompt with you're already authenticated for the cluster ready to go. And you get an hour of OpenShift usage. It times out after an hour, but it's a great way to try out some of the features of the platform and see whether you want to invest more time or not. If this looks like something you like using, we also have something called Mini-Shift, which is an OpenShift and a VM that you could run for as many hours as you like on your laptop. So that's what I do, kind of get unlimited hours with that, and then quick demos with this as needed. So they're both great solutions, and /operator framework has a bunch of pre-made educational scenarios that walk you through all kinds of hands-on scenarios to help build and deploy operators, either making your own custom operators or leveraging the community of solutions that the open source community is starting to build out. I've seen a lot of kind of seems to be tension between Amazon and some of these major cloud providers and some of the major database software providers like MySQL and Redis and MongoDB. MongoDB and Redis recently changed their license away from an open source license to a common clause license. And the folks I've talked to said it's really tough. They're trying to monetize this code. They do a ton of work patching it, securing it, and we're trying to give you a way to connect with those communities of people where they can distribute security updates with zero downtime, performance upgrades, all of that type of stuff that we need to distribute in a cloud-native way. Operators are our way of packaging and distributing that custom knowledge and working with the maintainers to get it done. We also have some additional, so here's a couple folks. etcd is started at CoreOS. Prometheus is another, I shouldn't claim that CoreOS is behind it, but a couple developers were employed by Red Hat and CoreOS. There's a really great Elasticsearch operator, MySQL. There's a huge list at this URL, github.com, operator framework / awesome operators. If you come up with a new operator that you would like to get the word out about, please let us know. I would love to add it to our list. We accept pull requests as well, so definitely let us know if you spot something cool that we should be spreading the word about. The operator framework is kind of our main bundle of tooling to help you get started. Most of the support today is around Go development and people who are going to extend Kubernetes, particularly using Go. That's where our freshest, most recent tooling is written in Go. We also are adding support for Ansible-based automation using the operator framework as well. So that's another main. We also have support for Helm charts. It's not a very major piece of it, but you could go from Helm to an operator using the operator framework. The operator lifecycle manager. This is how we assist people with distributing new operators outside of their cluster to external clusters. Folks would run a operator lifecycle manager in each cluster. And then this would check the operators, check outside the cluster, see whether an upgrade is available. You may have a checkbox for auto upgrade or don't, or things like that could be included in your operator. We also have support for sending back, depending on if your consumers or your end users are comfortable with this. You can send back telemetry outside the cluster through the operator lifecycle manager and get back telemetry on how many people in the world are using my super duper MySQL operator or whatever you've cooked up. You could get reports back from in the field on how things are going. And the operator SDK is kind of one of our last big pieces there. So really, we're trying to help you, give you the tools to be successful in being successful with Kubernetes, really. That's what we're trying to do. When Kubernetes does not fit the bill 100%, this is what you can leverage to extend the Kubernetes API and add new custom resources that make it very easy for your end users to interact with Kubernetes in a declarative way, where they have a spec and a status, and they could just say what they need, and they get, hopefully, whatever you've cooked up, right? And using the best tooling available from the upstream Kubernetes community. If you want to see our latest and greatest along this line of thinking, OpenShift v4 is all operator-centric. We have an operator that looks at the system OS and can re-image the machine and reboot it, depending on if the OS needs to be rolled forward or rolled back. So we can do really advanced things. We can also auto-scale at a platform level by calling out to external APIs in OpenStack or AWS or other external APIs. And that integration is getting kind of better and better over time. So keep an eye on try.openshift.com for our latest in the OpenShift v4 series. This includes the operator lifecycle manager bundled into the distro. And that's the easiest way to get started with our latest release. Operator framework URLs. Let's see if there's anything else I got for you. Any questions from folks before I wrap it up? Silence. I got one. Yeah.
Yeah, so how do you control the eventual fragmentation that's going to happen with these operators? Like you said, my amazing MySQL operator, and everyone can make their own operator. How do you control the sort of inevitable fragmentation of the total market of these things?
Yeah, that's a great question. I think.
Chef cookbooks and Ansible playbooks that are all over GitHub, and everyone's got their own Puppet manifest and this and that.
Yeah, that's a great question. So one of the really interesting things about so there's a one quick answer that I can give you, and it's kind of I feel kind of cheap giving you this answer. Well, maybe not. Operatorhub.io. We have a collection of operators that some of them have been vetted. You could see security, you could see usage statistics, depending on what's, that's a great place to go to see what's kind of production ready, is that operator hub. Yeah, that's my short answer. But I think you do have a very valid concern when you are defining something like my super awesome MySQL database. You're defining it as a cluster-wide term. So you can only define that once. And currently, every different Postgres vendor in the field all says, well, we want to be called Postgres, right? And so, yeah, I think there's a lot of work around kind of namespacing. You can add in within your resource version, you can put in a long identifier. So there is, this has been thought through pretty well, but I think the namespacing issue and the cluster-wide visibility of these custom resources is something that may change over time because there is some room for improvement in that space, I think. Great question. Thank you all for sticking around. These slides are available at bit.ly/extendedinfra, and we'll be at the Red Hat booth if you have follow-up questions. Thank you all.